And we revisit an idea from chapter 6. Chapter 6, we solved a lot of trig equations, but now we're going to be solving trig equations where we first have to use a bunch of identities just to get them to a place that they were in chapter 6 that we can solve them. So I've listed some strategies. One strategy, and we saw this in chapter 6. If you had a sine squared theta and a cos squared theta in an equation, you couldn't solve it because you had two different trig functions. If you could change it so you have only one trig function, then you could possibly solve it. And that one trig function, I put in brackets here in blue, like it has to be with theta only. You can't have one sine theta and a sine 2 theta. That also isn't solvable. The angle has to be the same. We're going to have to use skills in factoring. Sometimes you can't write an equation with only one trig function, but you can separate the trig functions by factoring. And the third strategy is if all else fails, just like a proof, you can change things to sine theta and cos theta. But because it's a solving question, you can eliminate fractions by multiplying. And maybe that gets us to a point where we could solve it. So we're going to do a bunch of questions that involve identities now and look at how they make it a little bit more complicated, but our goal is to get something in the end like we saw before in chapter 6. So question 1. We're solving for theta. We have a cotangent theta and a 2 cos theta. Can we get just one single trig function? Is there a way to change cotangent to just cos? No. You can change cotangent to cos over sine. So I'm going to use the third strategy. I'm going to change to sine and cos, eliminate fractions, and see what happens. So to start with, I change cotangent to cos theta over sine theta. And then if I multiply both sides of the equation by this side by sine theta and this side by sine theta, can you see that then your sine thetas would cancel out and you would get rid of the fraction? And you get cos theta equals 2 cos theta sine theta. Okay? I want you to think what you would do next. Because about 75% of students, what they want to do next costs them a mark on the test. So I want you to think about what you would do next. And if your answer is, oh, I don't know what I'd do next, I would do nothing, that would probably cost you more than a mark. So on an exam, what would you do next? Okay. I'm going to put the most common mistake here, and it's not really a mistake. It just makes it so that you miss some answers. If you want to divide by cos theta, do you see how nice that would be if you divided both sides by cos theta? The cos theta would go away, and you'd only have one trig function. Seems like a very good strategy. Okay? The problem with that strategy is if you look at this equation and do some simple mental math, can you see that cos theta equals 0 will work? If cos theta is 0 here and cos theta is 0 there, are those two equations equal? Yes, 0 is equal to 0. So if you want to divide by cos theta, you might be dividing by 0, which is a bad thing. Okay? So if you want to divide instead of dividing, factor. Well, in order to factor, we need to make one side equal to 0. And we can factor out the cos theta instead of divide. If I factor out the cos theta, will there still be one cos theta left, or will there just be a 2 left?
No.
Just the 2.
Just the 2. And the sign. Because you're dividing it out. Again, that's a place where our brain wants to trick us a little bit. Sometimes people think you take the cos theta out, you're left with just one cos theta. That's if you're adding and subtracting. Here we're dividing. Taking or factoring out is like dividing. And now that you have factored, when you split things up, now the cos theta is by itself. The sine theta is by itself. And from your pi plane, when is cos equal to 0? Pi over 2 and 3 pi over 2. When is sine theta equal to a half?
5 over 6.
Pi over 6. And 5 pi over 6. Reread the question. Did it say between 0 and 2 pi? I probably, because I wrote this, I made that so I'd be not frustrated in the end that I have to change my domain. So we have a question where at the beginning we don't have things that are the same. So strategy, change to sine and cos, get rid of fractions, and we got to this point where we might be tempted to divide. If you are tempted to divide in a solving question, you might be dividing by 0. Like, if you had divided, you would not get these two answers, which would lose you a full mark. You would still get the pi over 6 and 5 pi over 6, but you'd miss 2 of the answers. So we definitely want to try to factor when solving instead of dividing. Okay, next. Here we go. Turn to page 667. When we learn new stuff, it gives us more options, which can make some of the questions we've done in the past harder. Up till now, if you had a solving question and you had a 2 theta, your brain would say it's a multi-revolution question. But now we have solving questions that have 2 thetas that are sometimes also going to be double angle identity questions. And you have to decide, should I use a multi-revolution strategy or should I use the double angle identity strategy? And it's actually really quite easy to say which strategy you should use. If you only have the trig function with the double angle identity, this will be a multi-revolution question. If you have the double angle identity and another trig function, then you're going to want to use a double angle identity. So I'll let you write that down and we'll solve those in a second. So the first one, if you only have the 2x in one function, we'd solve this like a normal multi-revolution question. How do we solve multi-revolution questions? Well, first of all, we rewrite the domain for 2x. Oops, pi. Which would be 2 times around the circle. Then we solve like normal for 2x. What family is root 3 over 2 for cos?
Pi over 6.
Pi over 6 family. We'd have quadrant 1 and quadrant 4. Second time around, add 12 pi over 6, add 12 pi over 6. And then divide all of them by 2, which is multiplying by half. And we get our answers. So that was something we did at the beginning of chapter 7, multi-revolution questions. If you have a double angle identity and another trig function, this is one where you would use the double angle identity. So I change the sine 2x to 2 sine x cos x. And then you might be tempted to divide by sine x. So if you're tempted to divide, factor instead. So I'm going to move the sine x over and factor out a sine x, leaving me with 2 cos x minus 1. So sine x could equal 0 and cos x could be a half. This happens at 0, pi, and 2 pi. And was 2 pi included? Yes, I checked my domain. And cos of a half is pi over 3. And 5 pi over 3. So if you have a 2x in a solve question, it might be multi-revolution, it might be a double angle identity. And this is our way of determining which is which. Okay, we're going to leave